Hello guys and welcome back. Today is our day 2 of the 100-day question series for JEE Advanced, and this will be the question today. And let me give a brief overview first of all. This particular question is based on differential equations. That's pretty well visible, I guess. Differential equations, limits, and a little bit of inequalities. Okay. Like I am seeing a very common thing that in questions on calculus which are of a very high level, very high advanced level, generally inequalities are there in that question. Okay. And one more thing guys, like this would be like maybe a good news for you if you can solve the question. In the options, this is a single correct question. Okay. Single correct. Any one of A, B, C, D will be correct. So, and guys, let me tell you, this question will be the most interesting differential equations question that you have ever seen in your lifetime. You haven't seen such a question anywhere before, okay? I can guarantee. So, I guess we can start. And guys, I got a positive response on my day one video, so that's really good. So, if we can reach maybe 1,000 subscribers really quickly, then I can think of doing something better, something new, okay? I'm planning. So, let's see. Anyways, guys, I would like, if you want, you can try this question out, because this question is really like, even I would be really honest, I had a lot of difficulty in solving this question. Okay, like this small thing t dash x, this expression given here, you would never figure out how important this particular expression is going to be in solving this. Okay, it's very important. It's not just merely something that they have given a constant or some expression we are taking as a function, not like that. This will be a very important factor in solving this. Okay, so, and one more thing, this is not any normal, like don't try to frame any linear differential equation or something directly from this. It will come, something will come, but after a few steps of solving. Okay. So guys, I guess we are in a good position now to solve this. So if you want, you can try out. I will wait for a few seconds and then start off. Okay guys, I guess now we are finally ready to solve this question. So first things first, before doing anything, we have to solve this differential equation. Okay. So I will take a little bit, like maybe 3 or 4 seconds of your time, because I'm going to write the complete differential equation here. It's important. Basically, it is y times d2y by dx2 plus of, in a bracket, y times 1 plus x square plus of dy by dx times of 1 minus y tan y, and this is again whole multiplied by dy by dx plus of 2x times 1 minus secant y, and I guess a plus tan y. This thing is given to be equal to 0. So guys, I am actually defining some notation here, which is very standard, but still I will write. I am taking dy by dx everywhere as y, and y double dash as your d2y by dx2. Okay, and I am rewriting the equation once again. So if we rewrite this equation, this comes out to be y double dash plus of, within brackets, y times 1 plus x square plus y dash times 1 minus y tan y, y dash plus 2x times 1 minus of secant y plus tan y. This thing is equal to 0. Okay, so let's do one thing. Let's actually break open this bracket and all. So this will come out to be y double dash y dash 1 plus x square y dash whole square, I guess, 1 minus y tan y. Like guys, at the moment maybe things might seem a little bit boring, but all this is necessary, because the next step I am going to do, you will be shocked. Okay, 2x times 1 minus secant y plus tan y equals to 0. So guys, I have no space in this particular page here, so I am changing the page and writing. So guys, actually the next thing that I am going to do is, I will multiply this entire equation with cosine y. Okay. So y double dash cosine y plus y dash times of 1 plus x square times cosine y plus y dash whole square, and I guess this thing will become your, it's multiplied by cosine, right? Okay, so cosine y minus of y sine y. Okay, so I am breaking that open and writing y dash whole square times cosine y, and let's write it here only. Y dash whole square sine y plus of 2x times of 1 minus of secant, not secant y, I'm sorry. This is no longer secant y. This actually becomes cosine y minus 1 plus y sine y. And this thing is equal to 0. I hope I am correct. Let me check once. Okay guys, I actually missed out something. I just noticed in the question there was a little bit missing the thing. Like this is y tan y. Okay, I missed a small y. That small y could have changed the entire result. Please correct it. That's why actually y sine y is coming here. Here also you will have y. Okay, please correct that. So this thing is our final equation. Okay, and now what we are going to do is this particular bracketed expression inside, take it, we will define another function that is h of y, okay, in terms of y, please remember. And let this be equal to cosine y minus 1 plus y sine y. Like guys, this question is so high level, okay, like this question is not out of bounds for our syllabus, but still this is maybe the highest level of differential equation which JEE Advanced can ever ask you. So instead of like wondering whether if this question comes out in my examination paper, how will I solve this question, because it goes to be pretty long, okay, so instead of wondering how will I solve such a long question in my exam hall, the thing that you should wonder about is what, like you should try to understand is what is the idea in the question. Because JEE Advanced in history has asked a lot of questions which are only based on the idea. Maybe they will give you this differential equation and they will give you only 4 options pertaining to how you can solve this differential equation. Very possible, right? Nothing unusual. So if that happens, then only like still then the question will be short length, but it will be unsolvable. Like this particular part, you might be wondering why I am taking this function. Actually, this function will give us the entire differential equation. You will understand, okay? It's actually a little bit like, what should I say? Little bit hard to identify. Even I had a hard time to solve this, but that's the way. So you will understand things soon. Stay with the video. So basically the first thing that I am going to do is with this h of y, I am going to do a dh by dx. Or I'm sorry, not dh by dx. I should say, okay, wait. This is cosine y minus 1 plus y sine y, right? Okay. Don't write dh by dx. Write h dash y dash. That's better. Basically because h dash y dash is dh by dx, and like not dh by dx, it is dh by dy times dy by dx. So eventually you get dh by dx, right? So that's what we are actually going to do. So basically what you will get is your cosine y minus 1 plus y sine y. You will differentiate this equation d dy, and here you will have a multiplied y dash, okay. So guys, I am not going into this particular path simplification. It will be pretty easy. I am writing the result directly. It is actually coming out to be y cosine y times y dash. This is your, I guess, dh by dx. Now put this in a box because this will be important. So guys, I am changing the page and writing. Okay. So because we have dh by dx, we can easily find out d2h by dx2. So if that's the case, it will be d, I guess, d dx of y cosine y dot y dash. So if we partial, like sort of partial differentiation we have to do here. So basically this will be y dash times of y dash cosine y plus of y times d dx of y dash cosine y. I hope this is clear. It's simple differentiation, okay, multiplication rule. So now d dx of y dash cosine y, this thing, like this will come out to be, when we multiply, y dash whole square times cosine y plus of this particular part here. So use for this particular part, actually what we are going to do is I will write this as y times d dy of y dash cosine y multiplied by dy by dx. So it's the resultant same thing, right? So actually this will come out to be y dash cosine y dash whole square, I'm sorry, cosine y plus y dash once again, and d dy of y dash cosine y is something which is very easy to find. So I'm writing that this will come out to be y double dash cosine y minus of y dash sine y into y dash. Okay. So actually this particular thing, now I will simplify it a bit. I will go down. So to, like, if we simplify this thing, this will come out to be finally y dash whole square cosine y plus y double dash cosine y, and I guess this is your minus of y dash whole square sine y. Yeah. So this thing is your final d2h by dx2. Okay. And now guys, I will actually go on into our old differential equation which we calculated here. Okay. Or rather found, I should not say calculated. So at this particular moment, your work would be to observe my pen very carefully. Okay. This particular term. And after that, this particular term. First, second, and this particular term. If you group these three terms together, I hope you can understand it is d2h by dx2. Okay. Like the expression we just found, if you see it, these three terms make up d2h by dx2. If you go on to this, y dash times cosine y is your dh by dx. So this particular term becomes 1 plus x squared times dh by dx. And this is your plus times, plus I mean not times, plus 2hx. Okay. So that big differential equation is completely shortened. That was the reason I took h of y as this. Okay. I hope it's clear. So we will write down the final differential equation. So maybe I can use a different ink here. Guys, our final differential equation that is coming out is d2h by dx2 plus of 1 plus x square times of dh by dx plus of 2xh is equal to 0. This is the differential equation we are having. Now guys, if you actually see again this particular equation carefully, you can do something. Like we can write this as your ddx of dh by dx plus of 1 plus x square times dh by dx plus 2hx is equal to 0. So if you actually have a good practice of doing such sums, different, like not this sum, any differential equation, you will automatically understand that this particular expression that I have written here is nothing but ddx of dh by dx plus 1 plus x squared times h equal to 0. Now guys, if you actually integrate both sides, or rather than integrating both sides, I should not say integrate both sides, if you actually see this thing carefully, ddx of any expression will only be 0 when it's a constant. So that means dh by dx plus 1 plus x squared times h. This thing is equal to some constant c. And now this thing you have in here is a perfect linear differential equation. This is a linear differential equation. So that huge thing we had in the beginning, I reduced that to a linear differential equation. That's the actual beauty of this sum. Like, long way actually from that thing to here. Okay. That's the beauty of this sum actually. Beautiful sum. And JEE Advanced can just ask you up till this. They will not even bother to give you the options. They can just come until here, and like the thing that I did up till now, that is only a long question. Okay, so they can tell you what will be the form of the equation, and they will give you something like this. So that's a standard question, and this will categorize into the difficult questions. Okay, so I hope you will take some learning from this. Anyways, our sum is still not over because we have to evaluate this and go further. Okay, so guys, I'm changing the screen and evaluating it further. Okay, so because this is a linear differential equation, our integrating factor, if I take it to be say some mu of x, it will come out to be e power integral 1 plus x squared dx. And this comes out to be e power x plus x cubed by 3, or I should say e power x cube plus 3x by 3, and this particular thing was given to you as your t dash x, which I mentioned in the beginning of the question. So everything was hidden in the question itself. You just had to decipher. Okay. So guys, I can write this now. Like, we can write this as your h times integrating factor, which is e power x cube plus 3x by 3. I will bring in the t function later on. First, let's solve this. So this thing will be equal to c times integration of e power x cube plus 3x by 3 dx. Now this particular thing we can't solve, and we don't need to also, because if we see carefully, t dash x was given to be e power x cube plus 3x whole divided by 3. So from here we can actually write that t of x is integral of e power x cube plus 3x by 3 dx. And one more thing guys, like we will see this for later on, but still I am saying t of x is an increasing function. Okay, because if you see t dash x here is greater than 0, we will need this later on in our options, so better to know right now. So guys, I can write out now the final solution for this. This is becoming h of y times of e power x cube plus 3x by 3, and because this thing will actually result into a constant, like after integration we have a constant, right, and we don't have any limits here. So what I'm doing is I'm writing this as c integral e power x cube plus 3x by 3 dx, and introducing a constant d here outside. Like this is not in the integral. Okay, like this will come, so I sort of introduced it here. So guys, we can now substitute our t dash x and the final h of y which we took in the beginning. So the final differential equation would look something like this. It would be cosine y minus of 1 plus y sine y times of t dash x. This thing would be equal to c times of t of x plus d. This is the solution to your big differential equation. Okay. So now I guess we are in a good position to go into the options. So let's see what they have given us in the options once. Okay, so here are our options, and guys, I actually had an idea, because y tends to pi by 2 is given in two options, so why not we actually tend y to pi by 2 and see if something is coming. Like, it's a single correct option, right? So maybe one of a or b could be correct. So what I'm doing is I'm tending y to pi by 2 and calculating what comes in the differential equation. Okay, let's do that, because it's given in two limits, in two options. So if we actually tend y to pi by 2, then your h of pi by 2 comes out to be cosine pi by 2 minus 1 plus pi by 2 times of sine pi by 2. So I guess, okay, I will write cosine pi by 2 minus 1 plus pi by 2 times sine pi by 2. So this is 1, this thing is 0. So I guess this comes out to be pi minus 2 by 2. So what you have is your pi minus 2 by 2. Like I am tending it to pi by 2, so I am writing it in the differential equation itself. Times of e power x cube plus 3x by 3. This comes out to be equal to c times of tx plus d. Okay, so let's do one thing. Let's shift this thing to the right hand side. So e power x cube plus 3x by 3 is coming out to be equals to 2 divided by pi minus 2 times of ct of x plus d. Okay, so guys, actually if you take this to the right hand side using log on both sides, what you will get is x cube plus 3x by 3 is equal to ln mod 2 times c into t of x plus d whole divided by pi minus 2. And now actually what I can notice is this is a big surprise element because we have got our answer. This is exactly the form given in our option number B, where limit y was tending to pi by 2, x cube plus 3x by 3 was asked, I guess. I will check once what was asked. Yeah, exactly this thing was asked. So we have actually calculated y tending to pi by 2. It is limit y tending to pi by 2. I have calculated it in the equation itself. So this is what is actually coming. And if you see the form mentioned, they have two arbitrary constants a and b mentioned. So in this particular case, actually a here is 2 capital C and b here is 2 capital B. And now a and b are arbitrary constants. Similarly, c and d are also arbitrary constants, which doesn't defy our result, right? So actually B becomes the correct option to this particular question. Okay, so theoretically our question is done, but still I will go on into analysis of the other options as well, because we will analyze each option and seeing why they are not correct. So let's do that. Okay, so guys, in our option number A, what actually was given is limit x tends to 0 within a bracket limit y tends to pi by 2 x cube plus 3x by 3. Okay, this thing was given to be equal to ln mod 1 by pi minus 2. Now one thing that I would like to say here is maybe this is the easiest option, because first thing is x is tending to 0. So y tending to pi by 2 won't ever come first in roll. Actually x tending to 0 would come first in roll because inside the variables mentioned are actually x. Difference is in option number B, only y was present. So we had the provision to convert it using the differential equation to find out the exact value. But because here limit x tends to 0 is explicitly given, so our duty would be to give the variable x to the limit x tending to 0 first and then to y tends to pi by 2. So if we give x tends to 0 first, this thing will automatically become 0. So automatically option A becomes wrong. Like this is the most simple explanation to why option number A is wrong. Okay. So guys, in our next option, which is option number C, this is also a bit complicated to explain, like why it is wrong. So in option number C, actually what we had was 3 ln mod t dash x whole divided by cosine y by 2. This thing was given to be less than ln mod y sine y by 2 minus cosine y by 2, and this thing is whole divided by m t of x plus n, and we have to see whether this is correct or not. So first things first, guys, one thing that anybody can see and tell is that this particular numerator given in the RHS, this is nowhere to be seen in our differential equation in any solution. Nowhere this is to be seen. Okay, this is nowhere. So first things first, this particular RHS has no relation with it. Okay, still I will prove. So actually, if we need to prove that this statement is correct or wrong, like, see, our aim in the exam hall to actually, like, even this was, if this was a multiple correct question, our aim would be to always find out a contradiction case. Contradiction case basically meaning one case where this thing becomes false, so that we can easily eliminate. Okay, so that means that if we have even one case where this statement becomes false, then our option is wrong. So actually we have a case, that is x equal to 1 comma y equal to 0. And I will put this case and show you. Okay, just a minute. So guys, if we put our x equal to 1 and y equal to 0, our LHS, like cosine 0 is 1 and x equal to 1, which means LHS is, I guess, coming out to be x cube plus 3x. Why? Because I would like to remind you, t dash x is e power x cube plus 3x by 3. So LHS is x cube plus 3x. So in that, if you put x equal to 1, then it is coming out to be 4. And if you go on into our RHS and put these values, what you will get is ln mod minus 1 whole divided by m times t of x plus n. So this thing comes out to be minus of ln mod m times t of x plus n. So actually, this is the RHS. So 4 is given to be less than minus of ln mod m t of x plus n. So like any 5th or 6th class student will also say that this thing is absolutely wrong because the thing inside is greater than 0. Exponential functions integration would be, I don't know what it would be, like it would be something positive only, right? And m and n are arbitrary. And obviously, like, why am I talking about that even? Whatever the inside actually comes out to be, I should put this bracket like this actually. Yeah. Whatever the inside comes out, there is a mod. So it is always positive, right? Because m and n are arbitrary, so we have to consider a mod here. So that means the condition, like, this thing will not always be negative. Actually, it never will be negative, but still, m and n are arbitrary, so this case will not always be true. That should be a better statement in mathematics, which means that this option is wrong. And also here, one more thing guys, like this would be t of 1. So if m and n are positive, then very necessarily t of 1 will be positive, because I proved to you just a while ago that t of x is an increasing function. As why? Because t dash x is greater than 0. Okay, so guys, I guess it's done. And in option number D, which is the most simple option, I guess, limit y is tending to 0, x cube plus 3x. This was asked to us. Now this thing was given to be equal to 1 by 3. Okay. So now if we actually consider in our like resultant expression in the RHS, the main differential solution we found, in that we had in the RHS c times t of x plus d. So if we actually try putting it equal to 0, then y tending to 0 for this particular thing in the LHS where y is tending to 0, there would be multiple number of cases. Why? Because c and d can be anything. C and D are arbitrary. So there can be multiple number of cases where y will tend to 0, or maybe like not equal to 0, I should not consider, where y will tend to 0. There will be a lot of cases. So in that particular case, I can't say that this thing will always be equal to 1 by 3. Okay. That is actually a more logical explanation. And if you are in a bit of rush in the exam hall, then straight away say that y is tending to 0, here x is given, so no relation. But that would be like very absurd a statement to make. So this thing is actually better. C and D are arbitrary. I can't say for which C and D, which, how, like not which, how many number of C and D would be present for which that LHS would have its y tending to 0. So I can't say this thing will be exactly 1 by 3. It's not possible. Okay. You can say it will have multiple solutions also. That equation which we found, it will have multiple solutions. Okay. So guys, this question is done. Our correct option is option B. So like if we see how much we did, it's a long way. Correct option is B. Okay. So that's it for the day 2, guys. I hope you like this question, and like more than solving, I hope you could learn something from this. Okay. This was really great. So if you have liked my content, guys, please do like, share and subscribe. I end the video here for today. I will be back with day 3 with another good question. Okay. So that's it for today, guys. Thanks for watching.